Okay, here we come with the next set. Okay, this is memory and process. What is the purpose of RAM in the computer? Well, RAM is the working memory, it's the running memory, and it stores all our running application programs and user data, and even the operating system, then the background process, all of them run in the RAM. So if you have a large amount of RAM, that means your programs will run smoothly, and also the processor can access the RAM fast. Overall computer speed will be increased, and you can do more multitasking. What is firmware? Give an example of firmware. Now, firmware are the programs and instructions written into ROM chips, and every time when you give electricity, these programs will be executed. So remember, it's not only the instructions written into ROM, which is firmware, but also PROM. Now, PROM is a chip that you buy blank and then you write a program, and that's it, you can't erase, right? And then even flash memory like BIOS, BIOS settings can be changed, so that means it's flash memory, but it is also firmware. But generally, if you take firmware, that is the programs and instructions written into ROM, like these embedded computers, embedded devices, the program written into ROM is firmware. Firmware can be updated and changed. Describe flash memory is a type of EPROM, true or false? It's true, because flash memory is erasable and it can be rewritten. It is a type of EPROM. That's true. Describe the processor cycle. Now, processor goes through an iteration when executing these instructions. So first it does something called fetch. It fetches the instruction, and in this one, of course, you don't need to know in detail. Just know that it fetches the instruction, and then it has to be decoded into an understandable format, and then it is executed. In the sense, it's converted into ones and zeros, and then it is executed. So this is an ongoing cycle, the process cycle. It's an iteration, repetition, right? Briefly describe the clock cycles per second, which is used to measure the clock speed or the process speed. Well, this can be a bit confusing, and if you closely look at the book, clock cycles per second is measured in hertz. 1 hertz is 1 cycle. Actually, inside the processor there's a clock, internal clock, which gives pulses. These pulses are clock cycles, and for these pulses or clock cycles only, the processor will execute instructions. It can execute one or more instructions in these pulses or clock cycles. So how many cycles per second is the clock speed or the process speed? But it's not the number of instructions it executes. Back then, the process could execute only one instruction per cycle, but now we have super scale process which can execute more than one instruction per clock cycle. So this is measured in hertz, and then it goes to kilohertz, megahertz, and gigahertz. Now we use gigahertz. Write an expression to show how many clock cycles are generated in a second. Well, part of the question is missing there. Let's assume that we have a 3 gig processor. So if you are going to find out how many clock cycles are there generated in a second here, you just need to convert this into hertz, because hertz is 1 cycle per second. So 3 gigahertz converted into megahertz by multiplying by 1000, multiply by another 1000, you get kilohertz, multiplied by another 1000, you get hertz. Okay, so you can see 3 into 10 to the power 9, that's a billion. So you can see it's 3 billion cycles per second. So simply convert that gigahertz into hertz. So just the expression is fine. Briefly explain why multi-core processors are better than single-core processors, right? When you have multi-core processors, each core is a small processor built into one unit as CPU, and each core can process individual instructions at the same time. So it leads to parallel processing, right? So the process speed or the overall speed will be increased. And if one core is running at 2 gigahertz, the other cores also run at the same. And in the multi-core architecture, you don't need to have higher clock speeds. You can have lower clock speeds because you have multiple cores. This will reduce the heating and makes it more efficient than single core processors. And also there are physical cores and logical cores. It's always better to have a higher number of physical cores than logical cores. What's the answer for question number 7 in page 63? Well, page 63. Let me turn to page 63. It's a bit tricky question. Okay, it says which one of these describes the term clock cycle. At a glance, you see answer C and D are out. It should be either A or B. And if you look closely, A says the number of times per second that the processor can carry out instructions. B says number of instructions that a processor can carry out each second. So the answer is A, because clock cycle measures the number of times per second instructions can be carried out, executed. It's not the number of instructions, so be very careful there, right? It's A, number of times instructions are carried out. Alright, so that's memory and process.